Hello guys, this is my YouTube channel and we are going to see this week's topic. This is my channel, it's called Civil Engineer and Stuff. As I said before, this week's topic is seismic response of stiffeners in steel structures. So, what are stiffeners? Here we see two pictures. One is a steel building without stiffeners. Other is a building with stiffeners. Stiffeners is this element that it's added to the frames of a building. So it can be more rigid. Why are stiffeners important? Well, there are several types of earthquakes in Chile, which are classified into these four here, based on its tip. We can see the A is called interplate earthquakes. B, interplate earthquakes of intermediate deep. And of the four, the most important are the superficial or cortical earthquakes because they are near in the city of Santiago. So, what is the importance of the construction material? We see here that in the metropolitan region in Santiago, there are more than 1,155,225 houses built in concrete. And there is much less structures or houses built in steel. And that's just because steel, it doesn't have a really good behavior against the earthquakes. For example, the steel structures in Chile are fewer than concrete. The use of steel structure is basically industrial, and there are fewer specialized studies done on steel structures. So this picture is an example of a steel structure. So can we use steel in high-rise building? Yes, there are a few examples or a lot of examples in the USA. One of them is the Willis Tower, and it is completely on steel. So steel can be used in high steel structures. But what about houses? Because this was an office building. So what about houses? So there is few problems with steel. One of them is that when earthquake occurs, well, the house tends to move more than a concrete one. So it can be damaged because of the movement, of the lateral movement that the earthquakes imply. So what are we using stiffeners? Stiffeners are used to add a little bit more of rigidness. So in our frames. Right here we have a picture when we have a frame. A, it's with stiffeners, and B, without stiffeners. It can be applied in all the frames of the building, or mostly frames of the building. So the movement can be mitigated. This is a few examples of stiffeners. There are one stiffener. It's on a diagonal shape. This is in the red in the picture. There are the V-shaped stiffeners and inverted V stiffeners, X stiffeners, Z stiffeners. This is a few examples of stiffeners. And how do we put them on the frames of the building, of the steel buildings? And there are quite a few types, as I said before. These are other ones. This is a reinforcement done on a concrete building, and we added some stiffeners for the frames of the building. There's another example of stiffeners in the building. So how can we know for sure if the earthquake is going to be huge or a little one? Well, there is this web page of an institute that basically give us the seismogram. The seismogram is this that I'm showing here, that in the vertical axis, it has the acceleration, and in the horizontal axis it has the time. So that is a seismogram. This is a simplified process of what this web page do. It is very useful for my study. And these are basically when a earthquake comes in the building, we have the seismogram and we have the building. And how are we going to do this research? Well, with the seismogram, we apply to some structures that are built in laboratories like this, so we can test the results. What do we need to develop? Well, lighter structures, I mean lighter than concrete structures, very resilient and rigid structures. As the construction times in steel tend to be shorter, houses are expected to be cheaper than in concrete. So this is a really basic topic of the week in my YouTube channel. I hope that's it for it. That's it for it. So I hope you do well. See you next time.